So we've done a little work with inverse functions. Let's take a look at this exponential right here and try to take the inverse of that. So when we do that, we switch the x and the y and solve for y, but the problem is, how do we get this variable out of the exponent? And you could say, well, you could take the y root, but taking the y root of both sides doesn't solve for y. So what we've got to do is we've got to use a new form called a logarithmic form. Now here is our exponential in kind of like a parent function form, and this is your logarithmic in parent function form. Log base b of y is equal to x, for, or at least if we're trying to get this power down. Now the thing you'll notice, how do you get from one to the other? I use kind of a baseball reference. If we take the base in each case and we were to slide the base to the other side, so if I take this base and slide it to the other side and introduce the log function, then we have log base b of y is equal to x. Likewise, if we take a logarithmic form and take the base and slide it under the other side, that becomes the base, and we remove the log, it becomes an exponential. All right. Again, let's just write this out. Log base b of y equals x. That's how you say that. Now, what the heck does the log mean? Well, let's do a couple of exercises and maybe we'll get to some understanding of it. So if I take this expression, equation w equals x to the 8th, and change it to logarithmic form, I slide the base, so I have log base x of w is equal to 8. But that really doesn't give me any idea of what the function logarithm does. Let's try this one. This might help because now we've got a couple of numbers instead of a couple of variables. Slide the base, log base x of 5 is equal to 3. And that really doesn't give me much more insight. You know, the log of x, log base x of 5, that means nothing to me. So let's go here. Again, I've got two more numbers, and this says log base 7 of x equals 5. I now take and slide the base. I want to get this in exponential form, and I have x equals 7 to the 5th. All right, I get a expression here that I can solve for, but it really doesn't tell me what the log base 7 does. Now, here's a form where, in this case, I have three numbers, and it's different than the others because all the others had some variable in it. Now, when I slide the base here, this says log base 3 of 81 is equal to 4. Again, I really don't know what log means, but now I slide the base, and I get 81 equals 3 to the 4th. This is a statement that I understand because 3 to the 4th is equal to this 81. So now I can kind of get an idea of, okay, to get to this, from this 3 to this 81, I would have had to raise that 3 to the 4th power to get that. So maybe the logarithm means the following. And let's pull this puppy down. This is what logarithm means. What power of the base is the number? So this really says right here, what power of 3 is 81? Well, that's the 4th power. So then if we know that now and look at a couple problems, we should be able to do these in our head. What power of 2 is 8? Well, that's the 3rd power. What power of 5 is 625? Well, that's the 4th power. Now, what power of 6 is the 5th root of 36? Well, that's a whole nother story. So what I typically do on something like this is I say, I have no idea. I'm going to call it x. And now what I can do is I can use a different form to get some more understanding of this problem, I'm going to slide the base and make this 6 to the x is equal to the 5th root of 36. And I've seen problems like this before and know how to work with exponentials. I need to have the same base in order to know something about the powers. So this is 6 to the x. This is 36 to the 1/5 power, because that's what the rational exponents do. And this is 6 squared to the 1/5 equals 6 to the x. And therefore, x equals 2/5. So if I say, what power of 6 is the 5th root of 36? I say that's a 2/5 power. Here's a similar example. After doing a whole bunch of these, you might be able to do some of these in your head, but I kind of recommend these at least to get going. So this is our x. I slide my base. I get 1/3 to the x is equal to the cube root of 81. I'm going to use the power of 3 to get this guy moving. This is 3 to the -1 raised to the x. 81 is 3 to the 4th. Cube root is 1/3 power. So I have negative x is equal to 4/3. And x equals negative 4/3. This is a little bit different. I need to simplify this, and we have a variable in this. So now I can't call this x over here. I'm going to call it another variable. Let's say w. So when I slide the base, I say, all right, well then that's 5 to the w. And that's 125, which is 5 cubed, to the 6x. And now I can say that w is equal to 18x. So in this case, what power of 5 is 125 to the 6x? We get an expression as an answer of 18x. Something a little different here, we now have an exponential. Even though there's a log in the problem, or in the expression, this log is in the exponent. So this is really an exponential. So I'm hoping to be able to solve this using the logarithm function to help me. So I slide the base and I get the log base 7 of 4x to the 5th is equal to the log base 7 of w. Therefore, 4x to the 5th is equal to w. There's a whole property that says if you have the same base in the exponential as in the logarithm, then these kind of cancel each other out and you get this. But I hate that memorization because I can change it and make the problem a little more difficult, and that concept is not going to necessarily be valid. So I would just set it equal to another variable and then use your conversions. And that's all we've got. Until next time.